Okay, so this unit, we're looking at numeric methods of describing data. So thinking about statistics as a whole, start of stats is develop what is your question of interest and decide how are you going to collect data. So then the first thing we learned is collecting data, how to design an experiment, an observational study, what type of conclusions you can make. Once you have your data, you're going to put it in a graph. So that's what we did last unit. And now we're going to start analyzing it, or we're going to start describing it. So this unit mainly focuses on measures of center and spread. Today we're going to talk about both. We're going to learn how to do them on the calculator. Also, there's one last graph we haven't talked about yet. So if you would find this page, please. Here's what we're looking at. So we have quiz scores for 5 students. And those 5 scores are 2, 4, 6, 8, 15. I just made those numbers up, but they're easy to work with. First thing that we need to talk about is how to talk about the center of this distribution. So this is a sample. If we are talking about center refers to 3 different measures. Mean, which is the average. Median. Mode. Mode is technically considered a measure of center. Nobody uses it, though. So we're going to focus on mean and median. Median, you know how to find. Cross out till you get in the middle. There is no symbol for median. Instead, you would say that the median is 6 points. I'm assuming that that's the unit of our distribution. The median is 6 points. It's the middle observation. And then the mean, the average, you all know how to calculate, so we're not going to do that. That work for us? Okay. For mean, the symbol is X bar. So that is the symbol for sample mean. So the mean of a sample, not the mean of a population. You will very rarely be calculating any of these by hand. You're going to rely most of the time on the calculator finding things for you.
Should I close the door?
That would be lovely. Thank you. So here's what we're going to do is I'm going to show you how to put this information in your calculator and find the different measures. So right now in your calculator, I want you to hit the stat button. So in your calculator, hit stat, and then you should have 3 options at the top, and I believe the first option, the first menu is edit. So stat, and then it's going to say edit, and click enter, and you should be editing list 1. Do we see that?
Yeah.
Does anybody not have a list 1 on their calculator?
Edit.
Okay, what I want you to do is put these 5 numbers in to that list 1. 2, 4, 6, 8, 15. And when you do that, you can quit out. So put those 5 numbers in and then quit out of the list. So once you've quit out, the next thing that you're going to do is you are again going to hit stat. So again, hit stat. This time, though, go over to the calc menu, which stands for calculate. And we want to choose the first one, which stands for one variable statistics. And then it's going to look a little bit different depending on the calculator you have. If you have an older calculator, so Adam, yours might look like this, the one I gave you, it's just going to say this. If you have a newer calculator, it's going to ask you some questions. That's probably what most of you have. What is the first thing that it asks you for? List. I want you to put in L1. It's already there? Okay. If it weren't there for whatever reason, it's right above the number 1 on the calculator. You would go to second 1 and it would put up list 1. So then the next one it says is frequency list.
Yes.
Is there anything there?
No.
Just leave it blank.
And then calculate.
And then hit calculate. And you should see that last menu that I have. Do you? The one at the bottom? Okay, so what you should see from here, or what you should be able to identify, X bar at the top is the sample mean. N is the number of observations. And then if you scroll down with your arrow, it should say Q1, median, Q3. But do you see the median?
Yeah.
And you see that the median is 6?
Yeah.
Okay, so expectation-wise, if I ask you to find the median or the sample mean, just use your calculator. But here's what you need to show. You need to show a formula, substitution, answer. So for example, what I would show, X bar is the sum of all the x's divided by n. That's what that sigma means. I'm going to substitute some numbers. I normally substitute the first observation and the last. So the first one is 2, all the way up to 15. And then I'm dividing by 5. And that sample mean is 7 points. For median, you don't need to show any work. For median, you don't need to show work. There's not a symbol, just give the answer. Questions for me yet? Okay, this is something that you're going to do on the calculator a lot. So it's really important that we're able to enter the information in. Okay, some other things that I need us to know. Well, before I say that, we need to be able to interpret these values. So the mean would be the average quiz score. And of course, you would put that in better context and in a sentence than I did. The median would be the middle quiz score. So you're going to have to be able to interpret those in context. Some other things that you need to know. You need to know one more symbol. X bar, like I said, is the sample mean. If you took the mean from the population instead, so if we had the quiz scores of every single student in the class, it's this symbol. It's like a U with a little tail on it. So that stands for population mean. Anybody know what letter that is? What Greek letter?
Sigma.
It is not.
Yeah.
It is mu. That's mu. So that stands for population mean. Okay, question for you. If I changed this 15, so if that score instead was 25 and not 15, would it change the mean?
Yeah.
Okay. Would it change the median? No. Okay, so you got to be able to do that. Another thing. So obviously, like what we just went through, the mean is going to be affected by outliers. And so sometimes when you take a sample, what statisticians will do is they want to calculate the average, but they don't want to include outliers. And so what they will do is they will calculate what is called the trimmed mean. Trimmed mean is where you eliminate the highest and lowest observations. And then you calculate the mean of what's left. I think the thing that is hardest to remember with the trimmed mean, that hopefully you read about, is the trimming percentage that you are given is off of both ends of the data set. So if I say calculate a 10% trimmed mean, you're eliminating the lowest 10% and the highest 10%. So really it's 20% of the data in total. So if we took our 5 and cut off the lowest and the highest, that is a 1/5. That is a 20% trimmed mean, 20% off of each end. That is not very common, but it is used when there are outliers. Questions? Okay. You're going to have to be able to find mean and median for a raw data set like I give you like that. Another thing that is big on the AP test is being able to read computer output. So that's what's below. Let's say that I looked at 28 AP Stats students and how many times they checked their grades on the old grade book, which was called My Grade Book. Here is a dot plot. Here's what you need to be able to read from it. Down here is the computer output. You need to be able to read N, number of observations. The mean is the average. The median is there. And then for fun, you have the minimum and you have the maximum. So, there we go. The other numbers you don't need to worry about yet. One more thing about measure of center, and I think that's it. Sometimes you will be given, not even given, a data set will be described to you. So let's say that I have 100 data points. The question I have is which one would be the median? Take the average of the two in the middle. She would take the 50th, I guess not N. You would take the 50th observation and the 51st observation and average them. Don't actually, cross off from each end 49 times. If you can do that in your head, great. I cannot. So what I always do is I think of a smaller data set. So that's an even number, and I see, okay, I'm gonna need the two in the middle. Whereas if we had, let's say 47 data points, where would the median be? So divide 47 by 2, and you get 23.5. So you are looking at the 24th observation. How do we feel about that? Not bad? We're good so far? Okay. That is the basics of what you need to know about measures of center. There was one more thing about measures of center that I forgot we need to talk about real quick. So I already said this, but I want us to write it down. Mean is affected by outliers. Whereas the median is resistant. So let's say that you have a symmetric distribution. In a symmetric distribution, the mean will be about equal to the median. If it's perfectly symmetric, they'll be equal, but this is not a perfect world, so they should be about the same. If your distribution is skewed like this, first of all, which way is that skewed, left or right? Right. So this is skewed right, or positively skewed, and here's why. The skew affects the mean. So that tail will pull the mean higher. So in a distribution like that, the median is going to be less than the sample mean. And really, every time I say mean and median, I should be saying sample, sample mean, sample median, because there's a population mean and a population median. And then we have something like this. This is skewed left. In this case, the mean is pulled lower than the median, because the mean takes into account every observation, not just one. And again, we're talking sample mean, sample median. So those are the ideas with measures of center. That is what will be on your homework tonight. Questions about that before we talk about spread? Okay. This is the exact same page. It should be a few down in your packet, except this time it says describing spread instead of describing center. We're going to use the same data set. There are 3 measures of spread I need us to know, And just to remind us, when we talk about spread, I'm talking about variability or consistency. So smaller spread means that we have less variability, that our data points are more consistent. Okay, the easiest measure of spread is one that you already know, and that's just range. The range is a single value. It's the maximum subtract the minimum. So sometimes in your descriptions, people say something like the range is 2 to 15. It's not. The range is a single value. So if we look at our 5 scores, we would take 15 and subtract 2. So 13 points is our range. Has the same units as our data set. That is not very commonly used. Why do you think the range is not the most helpful measure of spread? Outliers. It's affected by outliers, and it only takes into account 2 observations. Okay, so the one that is more common is what's called standard deviation, which is related to variance. Okay, so these sample symbols for us. Sample standard deviation is S. When we square that, we get variance, which is S squared. If these numbers come from a population instead, we get that symbol, O with a little tail, and then squared. What symbol is that? What Greek letter?
Omega?
Nope.
No. My bad.
If you had just stayed consistent, you would have been right. What'd you say initially?
Oh, sigma?
Sigma. It's lowercase sigma. We are going to be using sample standard deviation and sample variance. Sample variance, pretty much useless, but we have to find it to find standard deviation. So here's the deal with variance. Same thing, you're going to show formula, substitution, answer. So here's the formula. We take each x value, subtract the mean, and square that. We add them all up, and we divide by n minus 1. So we're going to do that one time right now so that you see how the formula works. But then you will do it by using the calculator from that point on. So here are our x values, and our mean is 7, like we've already talked about. So we would take the first one, which is 2, subtract 7, and square it. Then we would take 4, subtract 7, and square it. 6, subtract 7, and square it. 8, subtract 7, square it. And then 15, subtract 7, and square it. And divide all of that by 5 minus 1. Okay, so 2 subtract 7 is 5. 5 squared gives us 25. And then we have 3 squared, so 9. We have 1 and 1. And then 8 squared, so 64. And we're dividing all of that by 4. And I don't know what that is. Can you all calculate?
25?
Well,
20.
100 by 4 is 20.
Oh, okay. Yeah. Okay, so 100 divided by 4, we get 25. So that is our sample variance. The thing that's important here, S squared, so our units are squared. So this would be square points. We don't care about that though. We want S, which is the standard deviation. So when we take a square root, we get 5. The reason that we use standard deviation is it's a lot easier to interpret just regular units than it is units squared. You do need to be able to interpret this. This is the typical deviation from the mean. So if we were to measure how far every observation is from the mean, this would be about the average. It's not exactly that, but it's about. Okay, we got a few more things to talk about and then we will be done with notes. I want to interpret this value in context because it's a little bit less intuitive. So if I asked us to write a sentence describing standard deviation, here's what we would write. Typically, observations in AP Stats quiz scores deviate by 5 points from the mean of 7 points. I believe in your homework, you're also going to have to interpret variance. Variance is just the typical deviation squared. So it's basically that same sentence, just squared. It's the typical deviation squared. Is anyone curious why we square and then eventually just end up taking the square root? Do you know why?
Yes, so that you eliminate the negatives and you figure it
Okay, so that you eliminate the negatives. Why do we need to eliminate those negatives?
They'll cancel each other out.
Yep. So if we were just to sum up all of those deviations without squaring, that sum will always be 0. That's the reason that we square and take a square root. Similar question to before. If I take this 15 and I change it, like the quiz score was actually 25, will that change the standard deviation? Standard deviation is the typical deviation from the mean. Does the typical deviation change? Yeah. What would happen to the standard deviation? Gets bigger. Yeah, the deviations get bigger. Another question. If I add another observation, so my quiz scores are 2, 4, 6, 8, 15. If I add another quiz score that's 7, is that going to change the mean? Not the mean. Is that going to change the standard deviation? Does it change the spread? Does it change the variability or the consistency of the data set? It does. In what way?
Would make it smaller.
It makes the data more consistent. So in this case, the standard deviation would get smaller because we added a data point that was more consistent. Okay, 2 last things I need us to know. On the calculator, do you see this S and sigma that both are on the calculator? So if your 1 var stats is still up, you should see the same numbers you saw before. And if not, just do it again and you'll see the numbers that I have up there. Okay, so here's the deal. The calculator calculates S using only the data you put into it. The calculator calculates sigma using some magic to come up with what it thinks the population standard deviation is. You will always use S except in one case. So you will always use S except in one case. The only time you don't use S is if it's blank. And that's not going to happen to us right now. But in the future, we'll look at data sets where S will just be blank, in which case you'll have to use sigma. But otherwise, you're just using S. For standard deviation, when you calculate it in your homework, I do not expect to see all this work. I want formula, substitution, answer. That's it. Okay. 2 last things down here. This is the same output. Here's the standard deviation. So if I asked you in your homework, find the standard deviation, here's what I want to see. Formula. That's variance, though, so standard deviation, we're taking a square root. We're going to substitute. So take some x values. So I have 0 minus the mean squared, and then the biggest one, so 174 minus the mean squared, and then I'm dividing by n minus 1. And then you're just going to take it right off the calculator, or in this case, the output, and you get 43.95 times. Don't do it by hand. Know how to do it by hand, but don't actually do it by hand. Here's what we're doing the rest of class. There's one example I want us to do. You can find this example that says 4.2 describing spread. We're going to do this example with someone next to you or a group next to you or as a class, I don't care. It's going to take, I don't know, maybe 20 minutes, maybe 25. We'll go over it, and then I'll give you time to start homework 1 or more reading notes. Is that fair? Okay. Okay, so here's what I got. I would be expecting to see the correct symbol, formula, substitution, answer. Symbol, formula, substitution, answer. For standard deviation, there should be a square root. And then that is your final answer. I want units. So you can either put it as $1,961.16 thousand or multiply it by 1,000. Second question. First thing, please make sure you pay attention to the units. It was in $1,000, so we're not adding 1,800,000 to the data set. When you divide those by 1,000, you're adding 1,800 to the data set. Now, you could calculate it if you had to, but you shouldn't have needed to. Those two data points are very consistent with the other cases. They should fall pretty close to the mean, so our standard deviation will get smaller. The spread is smaller. They contribute to making the data set more consistent. You could, though, of course, check that out of your calculator. For the last one, if you looked at all court cases, you could argue either way on this with a good argument. I would argue the standard deviation is going to be larger because there's a lot more variability. You're going to have some court cases that are really small and some that are very big. How do we feel about center and spread?
Good.
Not bad? Okay. I do want to tell you, you're going to learn a lot of things on the calculator, so it is very comfortable. It is very important for you to become comfortable doing these things on the calculator. There's something I want to show you on Schoology, and then we'll be done.